first I will explain this setting and trigger. After that we will go for the 3 tests, shot, check and search test. So we have test model. We have 3 different test models. Okay, engineers, now we will talk about the advanced distance module. So we will start with the setting tab. After we finish the RAW file and hardware configuration, now the third part is the test module, following our OMICRON Ohm's law. So we have a different type of test model. As you can see from the drop-down menu here, we have 3 options based on the relay manufacturer. We have constant test current, constant test voltage, and constant source impedance. Most of the protection relay depends on the constant test current. What is the meaning of the test current? We will specify a special value and specified value of the test current, and we will not exceed this value. It will be fixed, and we will change the voltage injection based on the impedance value to get the actual impedance reach. So most of protection relay use this module, test model, and we also some protection relay like SEL using the constant source impedance. Okay, and constant test voltage is very rare in the power system protection field. So we will choose for the Siemens 7SA, we will choose a constant test current model, and here we have to specify the value of this test current. And as you can see here, it's linked because of the color. If you need to check what is the value is linked to, you have to press link to X-ray, and you will realize that it's double the I nominal, which double 1 ampere, so it will be 2 ampere, and you can change this value, no problem. And here we have the maximum fault impedance based on the voltage and the current in single line to ground, line to line, and 3 line. Then we have the V maximum line to line based on the link. It's multiplied by the V nominal multiplied by 1.2. So 115 multiplied by 1.2, it's 138 voltage. And for some cases, you will find out that some test point is out of range because expected zone reach is more than the maximum fault impedance can be injected by this setting. So the workaround or the solution of this case is to activate allow reduction of I test. The meaning of this parameter, if the impedance value exceeds the maximum fault impedance can be injected by this test current, so it will allow the reduction of the voltage based on the impedance expected value to reach this amount of impedance. Okay, for example, if we have here 10 voltage and constant current is 2 ampere, so the maximum fault impedance will be 5 ohm. So if I have test point with a value more than 5 ohm, it will be out of tolerance and out of range. So what can I do? I can decrease the current or increase or decrease. I can decrease the current or increase the voltage to reach more than this value. So this is the benefit of the allow reduction of I test. So it will reduce the I test value to maintain and to reach to the higher impedance values. Okay, we have also here a fault inception. As you can see, we have different modes: random, maximum offset, zero offset, and fixed angle. If you need the CMC to be very specific with a fixed angle or the maximum offset, which means the highest amplitude in the sinusoidal waveform, and also a zero offset. And the most common and the default setting here is to use it as random. If you specify a fixed angle, you have here to enter this angle. Okay, and we have also a DC offset, which allows the CMC to superimpose a DC component for more realistic fault events. And we have also a load current, which simulates the pre-fault current before the fault state. And you can specify also the amount of current to be injected in the pre-fault state, because of some protection relay needs to sense the pre-fault before getting a trip command or a fault conditions. And here we have also ignore nominal characteristic. And if you click this ignore nominal characteristic, it will ignore this tolerance band for each zone. And this parameter we can get benefit if we don't sure about the characteristic of the impedance and need the CMC and test universe to guess the boundaries of the zone reach. Yes. So this is very beneficial in that case. We have also a search interval, which is the impedance between 2 adjacent points. So if we have a multiple test points, so the search interval define the impedance interval between 2 adjacent test points. Okay. We have here also times pre-fault, maximum fault, and post fault. But the only important thing here is to make sure that the maximum fault is more than the biggest time expected. So if you have 4 zones and the fourth zone is 1.2 or 1.5 second, this maximum fault time should be more than 1.5 second. Okay, this is the most important parameter in this field. Then, as we explained in the overcurrent module, we have also a time reference for initiating the timer, either with a fault inception or with a starting. If you have a start signal or a start binary input, you can define it also as a starting. Otherwise, you can keep it as default with the fault inception. So this is the time reference. We have also extended zones active. If you have Z1B as extended zone, which is occasionally activated with some types of event like manual close command for switch on fault, for example, you can activate this extended zones active. We have also parameter here, which is recommended to activate all the time, which is switch off at zero crossing. The meaning of switch off at zero crossing, if the CMC gets the feedback of trip command from the relay and this point corresponds to high amplitude of current or a special value of current in the sinusoidal waveform, it will wait until the nearest natural zero crossing for the sinusoidal wave and it will cut the injection. Okay, so this is for safety of the CMC and the test object as well. You can remove it, but it's recommended because of it's better for the safety of the CMC and also test object, and it prevents the current jumps. Okay, so if the fault inception coming at the highest amplitude of the sinusoidal wave, okay, the trip command will be assessed, but the CMC will continue injection until the sinusoidal wave next natural zero crossing. Okay, so it's a recommended option. Then we have also a search resolution, and this search resolution can be defined using two ways, relative and absolute. So we have 1% and 50 milliohm. So if you do a search test for the impedance plane, and between 2 points, between 1% of 2 points, and the decision of the relay binary output changed from trip to no trip or vice versa, it will stop the injection and it will get the information that there is a boundary here in the impedance. Okay, so this is the meaning of the search resolution in relative and in absolute. Here is the setting tab. We have also a trigger tab, which we can define the trigger condition using the trip command and the start command. If you like to have a start command, but you will have to choose the trigger logic to be AND gate or gate. And here is binary output. If you need to simulate any kind of binary output, any kind of event to the relay binary input, you can choose it from here. Then I will get back to the shot test. Here is our first test, which is available in the normal distance module. Okay, if you remember, here I can append some shot. As you can see, just put the cursor anywhere as you want, and then right click and put add shot. If you select shot at Z, it will be injected directly and giving you the trip time. But now I need to add multiple shots, so I will press add shot. So this shot in zone 1, which means the T nominal is 30 milliseconds as we define in the real file. Okay, if you remember. And here also you can activate the Z relative, which give you the percentage of the line length, and it can be also unactivated, but it's better to make it activated all the time. So if the zone will change it, it will be changed automatically based on the line length. So I can add more points in zone 2, in zone 3, and here is the expected time. As you can see here, here is 430 for zone 2, which is highlighted by red cross, and zone 3 also is 800 milliseconds. This is the first type in the fault type single line to ground. So you can choose the test point either by amplitude of impedance and angle, or by R and X, okay, as a Cartesian impedance, and also can be represented and displayed in Z relative or absolute ohm impedance. Here is for the single line to ground fault. If you need to duplicate this test point to the L2 to ground, you can make copy, shift and copy all test point, and go to for the second fault type, which is L2 to earth, and press paste, so it will be available here as well. Otherwise, you can append shots. What is the meaning of append shots? Now I will append some shots for all types of single line to ground, or line to line and 3 line, or all fault types, which have 7 fault types. So if I choose this option, it will be implemented. This point will be implemented in all fault types. So this option will save your time. Instead of adding shot by shot, you can specify these shots for all fault types if you are sure that the characteristic for the single line to ground is the same characteristic for line to line. Otherwise, you can add for the single line to ground one time, and for line to line and 3 line other time. Okay? So this is for the search test. Second test here is the check test. The check test here, I can add a check line, as you can see. So I will add append check line from the orange, just drag and drop like this way, and then click append check line. So this is check line. Simply, as you can see here, we have a tolerance band, which is 5% or 3% based on the relay specification. So it will take one shot here in the lowest tolerance, and one more shot in the highest tolerance, as you can see. And it will check the tripping time. This point should be instantaneous tripping, and this point should be 400 milliseconds because it's located on the zone 2. Okay, so it is the difference between this one and this one. It's only 1% from the tolerance band. Okay, so if this one is, if the tolerance band is 5%, so this one to be 1 before the 5%, and this one 1 after the 5% tolerance band, to assess the feedback of the protection relay. The decision and the tripping command shall be changed from 0 to 400 milliseconds, and by the same way here, it will be changed from 400 milliseconds to 800 milliseconds, and this one will be from 800 milliseconds to no trip, because it's outside all the zones. Okay, so this is a very quick, you can add check line, and you can add, you can assess the result. It's more quicker than the shot test, which you have to edit manually each time. Okay, just you locate any point and press and drag and drop. Take some time, then you can append check line. Now this is at 64, which is the line angle. You can add more, or you can add a sequence from here So it will allow you to define the start value, the stop value of the angle, and the angle step to give you multiple check lines. So I will check here all types of the fault loops, and I will define here from 0, for example, up to 120 or 110 to cover all the forward zone, and I will define the step of the angle to be 10 degree. So I will have 12 check line by that way to all fault loops. Then you can also make it relative to the line length, and here you have to define the origin. Okay, so the origin for me is 0 and 0. So you should have this one 0 and this one also 0. For example, here from start angle from 0, 110 with 10 degree, it will be 12. As you can see now, starting from the origin, and give you each 10 degree a check line. Okay, so you will have 12 check line at total, starting from 0 up to 110 to cover all the forward zone. Okay, you can do the same by checking fault types, all the fault types. We have also a multiple check line. You can add by the same way you can add for L2 to earth, you can add multiple check line. So it's expecting here, if you can see the test report for this check line, it will detect by the T nominal, as you can see here. So we have 2 points and we have 6 points, so it will give you all the tripping time. So it will detect by the tripping time. So if inside zone 1 it will be instantaneous, after in zone 2 it will be 400 milliseconds, and so on. Until it get outside the 3 zones, it will expect no trip. Okay, clear? So this is the second type for the test. It can be done in the advanced distance module. The third one is the search, which is the most common used to define the impedance reach. So for example, you can add search line, just move the cursor and select append the search line, so it will detect it as angle 0 degree, and it will check for the zone 1, zone 2, zone 3. So here it will give you the exact value of the impedance reach in each zone. Okay, and by the same way we can append sequence of line and quick test. If you press the quick test for example the line to earth, as you can see here, it will give you 3 search line, one at 0, one at 90 degree, and the third one at the line. This is the quick mode for the search line if you need to do a quick test. But if you need more angles and you need to specify angles, you can add multiple check lines. By the same way, you can add a sequence from 0 to 120 by step size of the angle. It will give you all types of ramps here. So the origin is 0. So I will start from 0, or you can start from minus 10, because this line is minus 22. So you can start with minus 10 up to 110, each 10 degree. So you will find 13 ramp, as you can see. So we will add it for all fault types, or as you like, single line to ground or 3 lines. So I will add it for L3 to ground now. As you can see here, the L3 to ground starting from minus 10, and each 10 degree it make a new ramp. So it will give you 13 ramp to test this setting. Okay. So this is the third type of test. Each one, it checks the intersection. For the search mode, the CMC and test universe will check the intersection between the search line and the impedance boundary. And within this tolerance, as you can see, for example, zoom mode. So this one will intersect with zone 1 here. And within this tolerance, if the value is here or here or here within the tolerance, it will be assessed as pass. Okay, which is 3% or 5%, as you define in the review file, and also the same for zone 2 and the same for zone 3. So it compares. It's the CMC and test universe know the expected intersection between the search line and the impedance characteristic, like 2.9 for zone 1, 4.4 for zone 2, and 5.4 for zone 3. And with this expectation, it will define what is the value exactly which intersect with the zone boundaries, and it will compare this value with the expected nominal value. If it is within the tolerance band, which is 3 or 5%, it will be assessed as pass. Otherwise, if it's outside the tolerance, it will be assessed as fail. Show you one example here. Now this one we did it manually. I will show you some protection examples. So you have in the test universe some example of use. So if you click in this example of use, it will give you some OCC ready-made and predefined for a special function. Like if we select a feeder protection, you will find distance, overcurrent, directional, overcurrent, non-directional, auto closure, power swing, and many more application with a PDF also explaining this kind of OCC. So if you select, for example, the distance, it will open in your test universe, and you have now example. And if you open the test object, you will find out different characteristic, not similar to what we draw. So here is the line length is 7.87, the line angle is 64, and the same as we did for the Siemens relay. But here the grounding factor is represented in KL with 0.6 and 0 degree. Then in the zone setting, you will find out we have here two zones in the forward direction and the other zone in the reverse direction. And to know the intersection of each point, as you can see, you can press the edit, and it will give you the coordinates of each line. So as you can see here is the same example, 2.9 and 6 with the same rotation. If you go to zone 2, press edit, yeah, it's 4.4 and 9.2. For the other zone, which is zone 3, now it's in the reverse. If you press the edit also, you will find the coordinates for each line. So for example, this line 1, which is here, it's intersect with minus r, okay, which is given in the parameter setting, and x is 0, and the angle is 180 degree plus the line angle, which is 242. Okay. This is an example for your question. And the line 2, once we started line 1, it's intersecting with the r value in a given value in the parameter setting, so it's minus 2.7, and x is 0, and the angle is parallel to the line angle characteristic but in the other direction, so it will be 180 plus 64, which means 244. Correct? Then, just we are starting by this line, so we will follow the direction of rotation, counterclockwise direction of rotation, so the line 2 will be intersect here with the x and minus x value, and the r is 0, and the angle is 0, because it's going in the same way of the positive r axis. Okay? Clear? So the line 3, as you can see, it will intersect, if you extend this line, it will intersect here with r value, which is given in the setting, and x is 0, and the angle is 64 because it's parallel to the line angle and in the same direction. So it will be 64. Clear? So line 4, as you can see here, it will be intersect with the origin 0, 0, and if you extend this, it will be here is 30 degree plus 90, so it will be 120 degree if you extend this line, because this angle is 30. Clear? So for the line 5, based on the directionality from the Siemens relay, if you extend this line, it will be minus 22. Here is the 22. Here is the 22 value. So if you add this 22, or if you subtract this 22 from the 180 degree, it will be 158, and also intersect with the origin. So this is an example, just to check. And here is the starting zone, as we explained in our presentation. There is some zones is used only for starting, so there is no unexpected trip happening in this one. Otherwise, if it's located inside the zone itself, okay, then you can press OK. And if you go to the trip time module for the phase meter or the face to face, you will check the advanced distance module. As you can see here, we define the short test for L1 to Earth. And also we can define for the line to line and 3 line as well. And it will intersect with the zone 1, zone 2, and zone 3 boundaries, and it will give you the tripping time based on the setting. Okay? And after that, we'll assess the T nominal with the T actual based on the tolerance you have defined in the view file, and it will give you the test result. Second test is the zone reach. Yes, as you can see, we have some predefined ramps. Some ramps started with the origin, and some ramp didn't start with the origin, as this ramp is starting from 1.414 ohm, and the angle is 90 degree. So this check line will check the zone 1 and the zone 2 only. And we have also some check lines for the Z4 or Z3, which is the reversed zone. As you can see, this is another ramp, another check line or search line to check the boundaries of the reversed zone. Okay? You can do the same for all fault loops. You can do the same also for a check test or a short test. So the search test, it define and test the zone reach for each zone in ohm and compare with the expected nominal zone. But the short and the check test just check the tripping time and differentiate between the zone